Oh, hi there. Thanks so much for showing up for your math learning. It's Mr. Jennings, your humble math servant, and we are looking at the topic of domain and range. Let's see if this is working. It seems to be working, but I have a new cursor because computers. All right, so our main goal today is to be able to identify the domain and range of a function. So we want to first know these words, handy definitions, and be able to express it, write down the domain and range, and use something called set notation today. Okay, so I'll share with you a really cool activity to do at home, and you can try it out. All right, so what are we talking about when we're talking about domain and range? Okay, I often think about like I'll get crafty here, and I'll show you. Okay, here is the grassy savanna, and there is a pride of lions. Here's a lion with its big mane and its hungry face and its lazy body and feet and big tail. Okay, and there it's a lion. Okay, and the lion rules over all the things that it can see. This is the lion's domain. It's all this stuff this way, and then jutting up, all majestic in the back, is this like beautiful mountain range. Okay, and that's very tall. Okay, so this is mountain range, and this is the lion's domain. Okay, and that's the metaphor that I'll use to remember which one's the domain and which one's the range. The domain is all the possible x values. So we're looking at x values. X is horizontal. It's anything that the function can take x-wise, and then the range is all of the possible y values. Okay, so those would be vertical. Those are how high can the function go, how low can the function go. So that's the range of outputs and the domain of inputs. Okay, another thing that we're going to have and we're going to use in this course are just distinguishing, are we working with a function that has integer values? So we're going to be using the counting numbers, maybe positive and negative integers, like 1, 2, 3, 4, 5. Or are we looking at real numbers, where we have all of those integers still, but we're also considering all the decimals and all the numbers in between, like continuous functions. Okay, so here's like a warm-up for us. Let's think about little Black History Month feature for you. Garrett Morgan invented the three-way traffic light in 1923. So a traffic light can do things like red, yellow, and green, all right? And it has like these inputs into a traffic situation. It can say green, and the output is people go. Okay? It can say yellow, and the output is people prepare to stop. Or they stop. Or they just go through. You make your judgment call in that case. And then red is the output that you get, the behavior that the input red causes to this traffic situation is people stop. Okay? Did you know that the three-way traffic light was invented in 1923 by Garrett Morgan, who invented a lot of other things, actually. He's an interesting fellow, and you can look him up. So, in any case, here are a few functions. Here's a function, and it's a very simple function. It only has 4 points. We could visualize it this way. Pion, pion. Here is the point 1, 0. Here is the point 2, 1. Here is the point 3, 2. And here is the point 4, 3. It's just those 4 points. Okay? It's a function because it passes vertical line test because none of these x values are repeated. Okay, so they're all unique. So that's good. But we want to identify the domain and the range. Okay, so this is the way we do it. We say that x is of the integers. And we can use like a double bold I there, or just say x is of the I, the integers. And then we use this horizontal bar to indicate more information is coming, or kind of you pronounce it such that x equals 1, 2, 3, or 4. That's it. Okay? And that's how we would say that's the set of all possible x values. And then if we were looking at the range, so that's the domain. Okay, so we are talking about, turns out I'm using orange for domain here, domain. But on the other hand, the range is the set of possible y values, and they're somewhat different. We have 0 all the way up to 3. Okay, so if we write the domain, we'll just keep working in gray. We would say curly bracket there. Y is of the integers such that y is equal to 0, 1, 2, or 3, like so. Okay? And that tells you all the possible values that x can take and all the possible values that y can take. And for style points, list them least to greatest. I wouldn't be taking off marks if you didn't, but I prefer it if you do. And so will everyone, so do that. Next, we have this function over here. Oh, look, it's a linear function, but it seems to start there and finish there, or maybe it finishes there and starts there. Okay? So then we want to say, well, another thing I notice about this is unlike this function, it's not just a collection of points, it's actually a continuous line that goes between the integers. So in this case, we would say for the domain, x is of the real numbers, and we can use like a bold R there. This this notation here, this E, is read as is of the. Okay, so x is of the reals, and then we list all the values that x can be. Well, I'm going to go the smallest one that x can be is 0. So that's the smallest value x can be. And then the largest value x can be is 8. So 0 is less than or equal to x, which is less than or equal to 8. That's how you say that. Okay? Now notice what I've done there. X is any number that is simultaneously bigger than 0 or even equal to 0, or less than 8 or even equal to 8. X can be on that sliding scale anywhere in between there. Cool, right? So now I've just listed an infinite number of numbers with one single line of instructions there, which is the idea. And then if I want to talk about the domain, well, I look at it here, sorry, the range. See, I flip them too, okay? I say them backwards too sometimes. The range refers to this mountain range. How high and how low does it go? So the lowest it goes is -2, and the highest it goes is 2. So we would say y is also of the real numbers, because it includes all those numbers in between the integers, such that, oops, that was weird, such that -2 is less than or equal to y is less than or equal to 2, okay? It's saying this is my range from there to there, okay? And I've said this is an inclusive range. It includes the endpoints. If you wanted to disinclude the endpoints, the way you would show that on a graph would look like this, okay? Rather than having a closed dot at the end, if we had an open dot here, and then let's say a closed dot there, the closed dot indicates include, the extreme point. The open dot indicates exclude. So if I were to change this situation, then I would have to say, well, x cannot be 0. X is anything bigger than 0, but not in fact 0. You see, it doesn't start right there. It starts just after, at like 0.000000001, or an infinite number of zeros, but then a 1. Not quite an infinite number of zeros, but you get the idea. Right after 0. Any positive number, but not 0, excluding 0. And then we would have to change y as well, because while we do include -2 here, we're excluding the maximum there, that 2. So I would just say is less than 2. Not less than or equal to, but less than. So that's how I would change in that case, to reflect, include, or exclude those points. Okay. Now, here is a thing that I saw Chase doing, because Chase is not a big fan of history, I guess. So he punted his history textbook off of the school, which is 12 meters tall. I don't think it is that tall, but maybe in some places it is. Anyway, he punted it like that. And guess what it did? The book is launched 1 meter into the air before it begins to fall, and it takes the textbooks 2.1 seconds to land on the road, which is 15 meters away from the school. So let's create a little graph here. Okay, so there's my this is my time axis, and this is my height axis. Okay, and here is the height of the school. That's 12 meters. It goes up 1 meter before coming down and landing on the ground at 2.1 seconds. Okay, that's this one. Where do we use this 15 meters away from the school? I have no idea. I actually don't know why it's in there. I should look at these sheets that I borrow from other teachers sooner. Because I could graph horizontal distance or I could graph time, but I can't really graph both unless I use 3 dimensions. So anyway, now I want to talk about domain and range. Okay, the highest that it goes is this point, the vertex of that there, which is the point 13. That's just like 13 high. Okay, and then let's see. And so then here we have time is 0 and height is 0 here. Okay. So the values of time is of the real numbers because we can certainly have non-integer seconds, like we could have 0.5 seconds. We even have 2.1 seconds there. It's definitely of the real numbers, such that 0 is less than or equal to time is less than or equal to 2.1 seconds. Okay? Because we start at 0, the time before that is meaningless. It's not something measured by this function. And the time after 2.1 seconds, I mean, maybe the book bounces or something and then stays flat, but it's a different function. Like it's something different is happening to its height there. So we kind of start the clock at 0 and stop the clock at 2.1 seconds. Height, on the other hand, height is also real because we can have non-integer heights even though all our heights happen to be integers. And we know that 0 is the smallest height. That's less than or equal to h, which is less than or equal to 13 is the maximum height. That's the highest that this function goes. It's never up there. It's always below that. Okay, so that's how you do it in this case as well. All right, so now let's keep going. Okay, so now for you, this is your task. To warm up with some of these and list their domains and ranges, and then do the problems in the textbook. So I'll post the link to the textbook problems in just a moment because they're not on the handout. But yeah, I'll post them along with the video. So with this one, what do you think the domain and the range is? Particularly since I can do this. Okay, I can say that goes off to infinity in that direction. This is a little different, I think you'll agree. Because x could literally go out there as far as it wants, or out there as far as it wants, and it just goes down further and down further. Okay. Y, on the other hand, range-wise, we have a clear maximum. This never goes above that. So this one would be x is of the real numbers. Done. X is all the real numbers, all the way out towards infinity and negative infinity. They're all okay up until that point. Okay. Y, on the other hand, the range, so we would say y is also real numbers here, but we have y is less than or equal to 3. That's our limitation. Y can go down to negative infinity, no problem. But it can't ever get higher than 3. Okay, so we say y is less than or equal to 3. Equal to is important there because this is included. That's the vertex. That does arrive at 3 before going back down. Well, what if we have f of x is equal to 2x plus 3? Okay. Well, this one, we want to be able to recognize what that is. It is a line that crosses here at the point 0, 3, because we get that from this b value, and then it goes up like that and down like that, off to infinity in both directions. We get that from this value. it travels over 1 and up 2, 1, 2, or back here negative 1 and down here negative 2. Okay, so there's our slope. And here we would say x is, of the reals. We can certainly use non-integer values there, but x can literally be anything all the way from positive infinity to negative infinity, not inclusive. And y is also of the reals. No limitations there on y. This one here, yes, it's a function. I can tell that because all my x values are unique. I would say x is of the integers here, and such that x equals 1, 2, 3, and 4. Okay. Y is also integer values, such that y equals, I like listing them smallest to largest, 5, 7, 9. You should list them smallest to largest. Why didn't you double list 5, Mr. Jennings? I don't need to. I told you once already, y could be 5. It could be 5 in 2 places, but I'm not going to tell you that. That's something you can see by looking at the function. Okay, let's keep going. That one's also a function, because it passes vertical line test. And we have x is again of the integers. Let's get our squiggle bracket in there, such that x is equal to -6, -5, -4, and -3. Okay, x can be any of those values. And then y is also of the integers, such that y equals -11, -9, put commas in between them, please, -7, and -5. Okay, so there's our y values that this function can take. And that's that. Oh, here's another parabola. Look, it has a minimum value. Look, it has little arrows going off that way to indicate it continues going in those directions. All right, so we would say, well, x is any real number. Oops, you want the right shaped bracket, the curly bracket here. 3 little lumps is ideal. Okay, and then y, on the other hand, the range, y is also of the real numbers. However, we have a minimum value there. So we would say 1 is less than or equal to y. Okay. Again, I'm listing it smallest to largest. 1 is the smallest possible value of y, and all of the other values of y happen to be up there. Okay, so any of those fall in the range, the mountain range. Okay, so I'm just going to pause the video and then get the homework onto here so that you can see what we're working on for our practice today. All right, here we go. So the homework is page 20, questions 1 to 4, 6, 7, and 11. Try these questions. Email me with any of your questions, and I look forward to seeing you hopefully on Thursday. Bye for now, everybody.